I'm going to solve problems related to normal distribution and ZScore table. Okay, assume that random variable x is normally distributed with the mean is equal 81. Standard deviation is 4. We need to find probability of x value less than 79. Okay, so first of all, we know that access to the ZScore table we can have only through ZScore. Okay, so with the data we have, we don't have direct access to the table. So at this point, what we are going to do, we are going to calculate ZScore first. All right, so let's see. Formula for ZScore. X minus mu over sigma. Okay, so we are going to get ZScore, which ZScore is going to represent this x, value of x for the table of ZScore. So ZScore is equal x less than 79 minus mu 81 and divided by 4. Okay, so let's see. 79 minus 81 is equal negative 2. Negative 2 divided by 4, this is 1, this is 2. We get negative 1/2, which is negative 0.5. Okay. What is interesting, first of all, I want to mention it that the table that I'm going to use is representing the probability that is less than, not greater than, because if I have here normal distribution, tail can be right tail, tail can be left tail, and there are tables for right tail, left tail, or there are tables for between. Okay, we are going to use left tail table because for us, it's for schools, we are using usually left tail table. And since we have x is less than 79, then this table is going to work perfectly without any modifications. Okay, so ZScore equal negative 0.5. Let's go to our table. We know that table is has 2 pages. One page is showing negative ZScore. Another page is showing positive ZScore. And here it is, it's showing here that it's the left tail table. See, it's showing here, table entry. That's why it's showing here. So negative 0.5. So when it has negative 0.5, where is it? 0.5, it's right here. .5. So I'm going, since second decimal is missing, so I'm going to use 0.50. Interesting, it's not shading. Let me see if this one or light one. Okay, this is this one, and then from 0. So it's the first one practically. It's not shading, it's coming right here. Okay, and this is going to be 0.3085. Okay, so when you have, instead of two decimals, only one decimal, then you just add 0. So it will be 0.3085. Okay. Let me move in the middle this one. Okay. So probability for Z-score less than negative 0.5 is going to be equal, how much we got? Let's see, I forgot. 0.3085. Okay. That means probability of X less than 79, okay, is equal 0.3085, which means 30.85%. So there is almost 31% that X is equal, X is less than 79. All right, so this is first problem. Moving to next one. Another one, assume that random variable X is normally distributed with a mean is 50%, mean is 50, I'm sorry. Mean is 50 and standard deviation sigma is 7. So we need to find probability of X greater than 34. This is interesting. I just told you that our table is showing less than, which is left tail, less than. So how we are going to deal if we have greater than? Okay, very easy. Let's say, let's do drafting. Normal distribution. So we need, let's say this is my 34. I need, oh no, it won't be 34. If mean is, hold on. If my mean is 50, then 34 will be from here somewhere. And to the right. This is my mu, 50. X is 34, it's much less, right? 34 here. So to the right. So what can we, how we can deal with this? All we know that this normal distribution is our 100%, right? Because all data are in there, 100%, or portion-wise is 1. So which means, if I have probability for this left part, less than, can I take 1? And minus probability for X that is less than 34, meaning this blue color, I will have this one, right? Left. Okay, let's do it. So ZScore is equal, my X is 34, minus mean is 50, divided by 7. So 34 minus 50 is equal negative 16, and divided by 7. Divided by 7, we are going to get approximately negative 2.29. I'm rounding till 2 decimals because table can show 2 decimals. Okay, negative 2.29. Let's see where we are getting. Negative 2.29. This is 2. Okay. And where is my 9? Here is my 9. It's coming right here. Negative 2. Wow, it's too thick. .29, so I'm starting from here. And there we go, 0.110. 0.110. 0.011. Okay, so probability from ZScore equal negative 2.29, or equal, I can put less also, is equal 0.011. So which is equal, which is the same thing. Let me put beside of equal, put less equal. So which is gonna be the same thing, probability of x less 34. So 0.011. Okay, now this is, we found 0.011 is this blue area. Probability 0.011. So to find this orange area, we are going to do 1 minus 0.011, and we will get, how much will be? That's right, 0.989. All right, now let's solve first problem. Assume the random variable x is normally distributed with a mean is equal 88. Standard deviation is equal 4. We need to find probability for x is greater than 76 and less than 80. Okay, what does that mean? Let me explain. Normal distribution. Okay, here is x. Okay, if this is our mean, let me make it bigger because we are going to use, if this is my mu average, 88, then 76, this can be, let's say, 80. And this can be, let's say, 76. So we need to find in between this piece. So what I'm going to do, my table shows less than, right? So this is what I want to do. I'm going to find less than 76. Let me fix this. It has to go as a asymptote. Okay. Let's say less than 76, I'll find this, can I? Yes, I can. And then I want to find less than 80. Yes, can I find it? All right. So now if I take this area of 80, which is this, and do minus area of 76, which is this, will I have this one? X is greater than 76, less than 80, right? Which is yellow area. correct? It will be this piece. Okay, let's do it. So, Z1 for 76 is equal, x is 76 minus mu is 88 divided by 4. Okay, 76 minus 88 is negative 12. And divided by 4, it's going to be negative 3. Okay, then, and so from there we need to go and find probability of Z-score less than negative 3, right? Less equal negative 3. Which is going to be the same thing as of probability of x is less than 76, yes? Okay, let's go find negative 3. Where is our negative 3? Right here. Right here, negative 3. Now, since we don't have any decimal notation, we are taking negative 3.00. And we are going to stop right here. 0, 0. That's all. And the solution is going to be 0.0013. 0.0013. Okay, next one. Z-score 2. Z2 is equal. Now we are using x as an 80. 80 minus 88 divided by 4. So it's going to be negative 8 over 4. It's going to be negative 2. So probability of Z2 less equal negative 2 is equal probability of x less equal 80. We put here also equal, because can be equal also. And that is equal negative 2. Going back to negative page again. Here it is. Where is my negative 2? Right here. So, and from here I'm going to continue with different color, because we're gonna overlap. So it is gonna be, no, I needed this one. Let me clean this piece. I didn't mean to clean everything. Okay. I'll be careful. Okay, till 0. All right, 0.00228. 0.0228. 0.0228. Okay, so this blue color, it's a probability 0.0228. Okay, let me move a little bit away. Let me see, let me clean this. I don't need this here anymore. Okay, this will be better. All right. Okay. So this is 0.0228. And this one, the whole, let's say, orange area, this orange area, it's going to be whole orange area 0.0228, and blue area it's 0.0013. So if I take from orange area, subtract the blue area, I will get in between, right? So it's going to be 0 point, so probability of x greater than 76 and less than 80 is equal 0.0228 minus 0.0013. Here 1, 2, 3, 4, 1, 2, 3, 4. Okay, 8 minus 3 is 5. 2 minus 1 is 1. The other 2 stays. And then 0 and 0 point. Okay, so this is going to be our answer. Okay. Solving problem. Let's see what we have. Let me move this table down. Oops. What just happened? Okay. In a recent study on world happiness, participants were asked to evaluate their current lives on a scale from 0 to 10, where 0 was represented as a worst possible life and 10 represent the best possible life. The responses were normally distributed with the mean is equal 4.6 and standard deviation is equal to 2.5. Okay, we need to answer on the following questions. So first of all, we are answering what's the probability of the random selected study participant response is less than 4. So we need to find probability of x is less than 4. Okay. So we already familiar, right? Less than 4. So it's going to be Z-score is equal 4 minus 4.6 divided by 2.5. We are getting negative 0.6. And we divide by 2.5. So if we take 0.6 divided by 2.5, it's going to give us negative 0.24. Okay, so which means x, where x is less than 4, which is equal probability of z-score less than negative 0.24. Okay, so because the z-score always represents x, right? And we use z-score to have access to table. As I said, x value doesn't have direct access to the table. So that is going to be negative 0.24, 0. Here it is 2. Where is my 4? If this is, let me write down. It's going to be, okay, 0.00, yeah, 0.01, 0.02, 0.03, 0.04. So I'm going to come right here, 0.2, starting here. And coming till 4. 0.4052. So 0.4052. Okay. So let's see what is the next question we have. Question B. need to find the probability that the randomly selected study participant response was between 4 and 6. Okay. So, again, we already have probability of x less than 4 is equal 0.4052. We have that. Next, we are going to do less than 6. So, z is equal, so 6 minus, how much was mu? 4.6, and divided by 2.5. Okay, so 6 minus 4.6, that is going to be 1.4, and we divide by 2.5. It's going to be 0.56. Okay, so probability x is less than 6 is equal probability ZScore is less than 0.56. That is going to be equal, let's see, 0.56. Pay attention, ZScore is positive, so I'm going to second page because there are two pages. One page is negative, one page is positive. If you watch the video for ZScore table, 0.56, here it is, 0.5, and I'm going all the way to 6. There we go. It's going to be 0.7123. Which means, so probability between x is greater than 4, less than 6 is equal 0.7123 minus 0.4052. That is equal, 3 minus 2 is 1, 12 minus 5 is 7. Here it's going to be 0. 7 minus 4 is 3. And we get 0.3071, which is going to be 30.71%. Okay? 0.3071. All right. So, and the last question, question C. Find the probability that x is more than 8. Okay. So, Z-score is equal 8 minus 4.6 over 2.5 is equal 8 minus 4.6 is 3.4, and divided by 2.5 is equal 1.36. Again, positive. Okay, so we are moving to positive table, 1.36. So 1.3 I will find here. And going again to 6, which will come from here. 0.9131. Okay. .9131. Okay, that is probability of Z-score less than 1.36, and that is equal probability of x less than 8. we need greater than 8, right? We need greater than 8. Remember what we have to do? Correct, we need to subtract. This is 1, the entire database here. So if it's if it's x is 8, so we got less than 8. Oh, it's 0.91%. So of course it's going to be much more than that. Let me see. This is going to be 8 because I'm seeing here 0.9131. It's a 91%. So it's going to be way close to the end. So if this is what we got, this area is 0.9131, then greater than is going to be 1 minus 0.9131. Okay, so we get 1 probability of x is greater than 8. It's going to be 1 minus 0.9131, and that is equal. So 10 minus 1 is 9, 9 minus 3 is 6, 10 minus 1 is 9, 9 minus 9 is 0. We get 0.0969, which is going to be 9.69%. Okay, but this is your number, 0.0969. Okay, so I think this will help you make a lot of questions much more clear, and I see you on the video where I will record finding x value from the ZScore table. Now here is a question. What's the meaning of this? Why do we need all this to know? What's the problem for this one? Here is example from you, from the business area. Let's say I am in business of baking bread, and every week I take to the grocery store about 500 breads to sell, and by Thursday night everything is sold. So as a business person, obviously I'm going to think, okay, if all breads are sold by Thursday night, maybe I can bake more, because there is a Friday, Saturday, Sunday, before on Monday I deliver again. Is it legit question? Of course it is. So what you gonna do? How much more you gonna bake it, guys? Nobody knows. So you can guess. It can be too much and you will waste it because the bread won't be sold. Or you can guess it and it still will be not enough, will be sold by Saturday night, and Sunday will be empty. So for that reason, so let's say you figure out approximately 100 more bread, right? And that will be your X. So given your average, in average how much you sell, let's say in average you sell 500 plus minus 50 breads. So between 450, that's your standard deviation, plus minus 50 breads. Because standard deviation, nothing else but error. So assuming that within 4 days you sell 500 plus minus 50 breads, so, and you are thinking to sell 600 bread, right? So you put 600 as an X, 500 as an your average, and 50 bread is your standard deviation. And based on percentage you get, you can figure it out if it's worth, if it makes sense to bake that much more bread or not. If you get, let's say, 80% and higher, by all means, go ahead and be confident you can sell it. Go buy ingredients and bake it and sell it in the grocery store. I mean, why do you? I started with me selling, okay. But what if you, let's say, decided to sell 100 breads and it came out with 40%, okay? So obviously 100 breads, it's too much, because 40% is not enough percentage to go and buy it. But then you want to know how many breads will make 80%, 90%. Okay? And that's exactly what I'm going to do in next video. So go backwards, take 80% from the table and see what value of X can match to that 80%. See you in next video. Okie dokie.